purpose is to analyze angular motion and conservation of momentum and energy, and to calculate the coefficients of kinetic friction for different surfaces using a fixed pendulum mechanism.
In order to analyze the dynamics concepts of angular motion, conservation of momentum, and kinetic friction, we constructed a fixed pendulum using recycled materials. The frame of our mechanism was a modified shoebox, our striker was a golf ball, which was suspended from a straw mounted in our frame, and our projectile was an empty marker box. The pendulum was operated by retracting the golf ball to 90 degrees from the starting point, releasing it and allowing it to strike the marker box. We then measured how far the box traveled from its starting point. These steps were repeated on 3 different surfaces: Formica countertops, carpeted floors, and polished concrete.
For our project, we developed a set of assumptions and constraints that were essential to the calculations in our project. First, we assumed constant velocity and acceleration of our pendulum. While this is of course not actually the case because of the inconsistencies in our human-controlled experiment, for the ease of calculations this is a necessary assumption to make. Second, we decided to neglect energy loss due to the collision. This would make our results slightly less accurate from what they would actually be. But by assuming negligible energy loss in a perfectly elastic collision, we can ignore the small losses due to friction and other interactions, thereby making our calculations much simpler. Third, we decided to neglect air resistance in all of our calculations, as it would have such a small impact on the results. And finally, we decided to neglect friction in our pendulum string, as it would be difficult to calculate and relatively insignificant.
We also came up with possible sources of error. This included frame distortion, the fact that we cannot account for air resistance, we had a limited degree of measurement, and release point variability, and finally, rotation of the box while sliding.
In order to compare the coefficients of kinetic friction of the 3 different surfaces, we began by using conservation of energy on the pendulum system. This allowed us to find the velocity of the ball right before impact. The velocity of the ball is labeled VA. The second step was to analyze the collision between the ball A and block B. Conservation of momentum was used for this. However, the velocity of ball A and block B after the collision are both unknown. The velocity of ball A after the collision can be found using conservation of energy based on the average height that the ball swings up after the collision. After this is found, it can be plugged into the conservation of momentum equation to find the velocity of B immediately after the crash. Finally, the distance the block slides forward is used to analyze the force of friction. The work-energy theorem is used to solve for the different coefficients of kinetic friction.